What's up, everybody? Mr. Kozad back with another video lesson. This time we are jumping into calculus lesson, volume by slices, part 2. Hopefully you've already watched part 1. If you have not watched part 1 yet, stop what you're doing here and go find the link to part 1. It's on my page, one of the first things you'll see if you go to my account. I would love for you to watch that first and then come and check out part 2. So all you need is a few things. Number 1, you need to know that today is a great day to be alive. Number 2, you need something to write on. Number 3, you need something to write with. So you got those things. Let's get after it. Here we go. So 5.2, volume by slices, day 2. Now there's a couple of notes that I want you to keep track of before we even begin. Okay. Reminder number 1 is what we're going to look at today is what happens when our base is actually a circle. So you need to remember that x squared plus y squared equals r squared is the equation of a circle. Okay, it's an equation of the circle centered at the origin, which is all we need to do for today. Okay, so it's the equation of a circle. And also remember that when we find volume, okay, volume is the integral of area. So we're going to look at the area formula of some of these cross-section pieces, and we're going to integrate those formulas to find the volume, to go from, if you integrate area, that gives you a volume equation. And the last thing to remember here is that whenever you see a of x, that's talking about the area of a cross-sectional piece. Okay, so again, if you need more help on this, go back and watch volume by slices part 1. Here we go. Problem number 1. Okay, find the volume with the indicated base and the indicated slices. Okay, so this is what I was talking about earlier. Here we've got the equation of a circle. And this is a pretty easy circle because the radius is going to be 3. Okay, remember that the equation we just wrote down is r squared. So r squared equals 9, which means the radius here has to be 3. So first step is I am going to draw a sketch of this circle. So I'm setting up my x-axis, my y-axis, and I always get so nervous about this. So I'm going to try my little shape tool here to see if I can get it just about right. Perfect. Okay. So there's my circle. Again, that circle has a radius of 3, so that means that it goes out 3 in each direction. So that coordinate there is going to be 3, 0. This one over here is going to be negative 3, 0. And what I'm going to do is I'm going to rotate this shape just a little bit on my screen so you can kind of see maybe a better picture of what it looks like in 3 dimensions. When we use the circle as the base and we build, what are we doing here? Squares, okay? Square bases, when we build squares that come up perpendicular to this circle to make a 3-dimensional solid. So let's build one right here. We'll build one right here. We'll do one right here, and maybe try to sneak another one in right here. So again, what we learned in volume by slices part 1 is we're basically making whatever shape we're asked to make here, and we're constructing this by building these shapes that come straight up from the circle, okay? It's kind of hard for me. I'm not great at seeing visually 3-dimensional things, so this one's kind of hard for me to see. You might need to go back and watch me draw that again. I know it went kind of, oh, that's cool. So I can actually build it like this. Cool. So first square, second square, third square, fourth square. You can kind of start to see the 3-dimensional figure take shape here. And remember, there's infinitely many of these squares that exist. It's impossible for me, and honestly, it would take me all day to be able to try to draw that accurately. So here we go. So square bases. So let's start here with our area formula of a square, which we know is just s squared. Okay, where in this particular problem, we need to figure out what does s equal, okay? And this is actually one of the more difficult parts of this problem, okay? So I'm going to slide this down here because I need a little bit of room to work. Okay, so I know to figure out the side, I need to figure out this dimension right here, okay? And technically, if I find this part, I can just double it because this part and this part will be the same length. So I'm really looking for this part here. So really what I want to know is at this x value, what does y equal? So in order to do that, I'm going to take the equation of my circle and I'm going to rearrange it, and I'm going to solve it for y. So that would give me y squared equals 9 minus x squared. And then if I square root both sides, I get y equals plus or minus 9 minus x squared. Okay? So my side length here, again, the side length is from this x value, whatever it is, up to the y value there. Okay? So I'm going to use, the side length is 2 times the y value. So that's going to be 2 times 9 minus x squared. So when I actually plug that in to find the area, I get 2 times 9 minus x squared, and that gives me 4 times 9 minus x squared. So now I can build my integral. So I'm going to integrate this from, okay, left bound. Left bound is -3. Right bound is +3, from -3 to +3, because that circle has a radius of 3 in each direction, from -3 to +3. And then I'm going to take my area formula, 4 times 9 minus x squared, and I'm going to integrate that with respect to x. So again, this is a pretty easy integral to calculate here. That ends up giving me 4 times 9x minus 1/3 x cubed. And again, we're evaluating that from -3 to +3. And I will let you plug and chug that. Plug 3 in for x, and then plug -3 in for x and subtract. And you should end up getting 144 units cubed. 144 units cubed would be the volume created by that shape. Okay? Very similar to part 1. The only thing that's changing here, again, is we have circular bases. Circular bases. All right, so example 2, find the volume with the indicated base in slices. So that looks familiar. We're keeping the exact same equation, but we're changing the shape. So it's semicircular bases. Okay, so again, I'm going to draw a picture of that shape. So I've got this, and I've got this. So that's not going to be great. Oh, that's why I didn't pick the circle thing. So let me do my little cheat sheet circle thing. Okay, and there's my circle. It's not perfectly centered, but that's okay. So then I'm going to rotate this so we can start to see the 3-dimensional attributes of this taking shape. So I'll do one there, do one here, and I'll just do one here. I'll just do 3 on this because hopefully you kind of have an idea on this. So semicircular bases. I don't want that. So semicircular bases are going to come up like this, and come up like this, and come like this. So again, as I deconstruct those, you can see as I'm building these shapes, we're creating a 3-dimensional solid. Like imagine this circle flat on your desk, and these semicircles are stacked up perpendicular to your desk. Wherever your paper is right now, imagine those semicircles, those half discs protruding up out of the paper towards the ceiling of your room, or wherever you are, towards the ceiling, and they progressively get larger and smaller depending on where you stop on this circle. Okay, so the area formula here is a of x equals 1/2 pi r squared, because it's half of the area of a circle. Okay. And then I need to figure out what r equals. Well, r here is the radius, so it's half of the diameter. So r is going to be this little section here. So actually, remember in the last problem, we had to double this length here. We don't have to do that for the circle because we only want half of this whole line. Okay, this whole line's the diameter, and we only want half of it. So we're just going to take, the radius is going to equal whatever y equals. Now, just like we did on the last problem, we're going to have to take this equation and rearrange it. So we know that we have y squared equals 9 minus x squared. Square root of both sides, we get y equals 9, plus or minus the square root of 9 minus x squared. Now, we go back and we plug that into our area equation. So we have area equals 1/2 pi times r squared. Well, r in this case is the square root of 9 minus x squared, and we're squaring that. So we get 1/2 pi times 9 minus x squared. So that is what I'm going to integrate. Okay, so I'm going to take the integral from -3 to +3 of the area of a cross section. So that's 1/2 pi times 9 minus x squared with respect to x. And I need a little bit more room, so let me do this. Here, give myself a little bit more room. Yeah, sorry. Okay, so a little bit more room. So that derivative equals 1/2 pi is a constant, so it can slide out. It's going to be 9x minus 1/3 x cubed, evaluated from -3 to +3. Again, I'll spare you the time of going through and plug and chug this for you, but all you're doing is plugging and chugging. Plug the 3 in for x, get a number. Plug -3 in for x, get another number. Take the difference of those two things, and you should end up getting 18 pi. Now, there is not a magic way that I know that that's 18 pi other than the fact that I'm using my notes that I already made before this video. Wizard of Oz moment. Now you know this my secrets, okay? But again, you should be able to plug and chug that and be okay. That's not too complicated of a thing. If you've made it this far in calculus, you should be able to plug and chug on that part to actually evaluate that integral. Okay, so one more problem together. We're going to look at what happens when we have isosceles triangle slices. Okay, so again, same thing I've been doing. I'm going to draw the picture first to try to help you see actually what's happening here. So this time, as you think about your circle, okay, think about, shoot, I did that last time too. I want it to be almost a perfect circle, okay? Imagine isosceles triangles are what are coming up off of your paper into the sky as you're building this shape. So let me take this and rotate it again. Rotate that a little bit. Again, the rotations are just kind of to help us maybe visualize the three-dimensional effects a little bit better, okay? So remember, an isosceles triangle is a triangle that has two sides that are the same. So you can sort of see that as you would construct those, you'd end up getting a bunch of those right next to each other. As you go from the ends, they get larger. In the middle, it's where it's in theory the largest that it'll ever be, okay? So let's talk about area here. So the area of a cross section, since an isosceles triangle, is 1/2 base times height, where base and height are the same thing. Base and height equal each other because that's the definition of isosceles. So here we got to figure out, is it 1y or 2y? So if you look at the shape, the actual base is this entire length. So we need to actually, when we do this, multiply the y value by 2. So same thing that we've been doing. We rearrange x squared plus y squared equals 9. And I'm going to just go ahead and write to it because we know what it is. We've done it twice already. Plus or minus the square root of 9 minus x squared. Okay, so when I actually build the area formula, I have 1/2 times the square root of 9 minus x squared times the square root of 9 minus x squared. Okay, so that gives me 1/2, and when I take those two roots and multiply them, I end up just getting 9 minus x squared. So that's what I'm going to integrate. So we're going to take the integral from -3 to +3 of 1/2 9 minus x squared with respect to x. So that integral is going to be 1/2 times 9x minus 1/3 x to the third. And we're, again, evaluating that from -3 to +3. That is an ugly -3. Let me redo that. -3 to +3. Again, I trust you to plug and chug. Plug it, chug it, see what you get. Should have gotten 72u cubed. That, my people, is all you need for volume by slices day 2. Again, the only change here is that our base became circular, which meant as we found like the side length of the square or the radius of the semicircle or in this case, the base of the isosceles triangle, sometimes we had to multiply that y value by 2 in order to actually capture the appropriate length. Hope this was helpful for you. If you didn't watch part 1, this was probably really confusing. Go back and watch part 1, volume of slices. Part 1 would be a great thing for you to check out. Check out some other videos. Hope this was helpful. Love you guys. Talk to you later.